Okay, so you want to print one of my rockets. Now, these rockets are ultra lightweight because they are printed in spiralized vase mode. That means there's a single perimeter. These structures you see inside here are structural reinforcement ribs. So basically, one side of the fin is flat, and the other side of the fin has a small slot in it. And the nozzle will go in and then back out, touching this other side, fusing these parts together. So you get this nice, strong, rigid part without having to create a whole bunch of infill. So you're going to print these with most of them are going to be printed with no top layers, no bottom layers, one wall in spiralized phase mode. So single wall, single outline corkscrew mode. Now, to do that, you have to properly instruct your slicer on how to do that, because I'm using some little tricks and tweaks in order to make this slicers do what I want them to do. And you probably do not have Simplify 3D like I do. If you do, I can give you a factory file and you're good to go. You're probably using a free slicer. So the only slicer I support is Prusa slicer, because so far it's the only one that will correctly slice these files. Flash print gets pretty close for a lot of them. Cura, just forget it. It doesn't work. It absolutely butchers the files. Basically what's going on is that all slicers, in one way or another, attempt to fix bad models. They assume something is wrong, like this one here. This is, see how it says auto repaired 4 errors? Actually, you probably can't see that. See how it says auto repaired 4 errors? It's not really any errors, probably not. Most of them are minor, but because of the little tricks that I use to make these files work. So here's my flying saucer. You can see it's all single outline corkscrew. Because of the little tricks that I use to make this happen, some slicers will delete a valid portion of the model thinking it's an errored portion of the model. So for example, this rib here is 0.8 millimeters away from the outside edge of the model. This one here, as you can see, goes all the way through the model. I get into more. I have another video on the theory of that. What you need to understand is we need this model to print without any glitches. So the first thing you're going to have to do when you slice it is make sure it actually slices correctly. And one of the things you have to do is look at the model from the side and make sure it didn't delete any layers. The most common way you'll error is it'll either delete an entire chunk of the model and you'll know it right away, or if you don't look carefully, you'll miss it. Sometimes one line will be deleted, and that can cause the model to fail. You can actually see that on this model here. I had to reslice it because right there, it deleted one layer, one line. As you can see, I can push in on that because there's no layer there. The layer did print on the inside, but it didn't print on the outside. So I have to reslice that model because I missed that when I was slicing it. I'm going to show you how to configure the slicer to correctly slice the model. The primary thing you have to change is, well, I'll just go through them all. So layers, let's see here. On most of these models are going to be 0.2 and 0.2 millimeters. Some of these models can print at 0.3 millimeter layer height, which will increase the speed. But the model I'm doing today is one of the flying saucers, and it cannot be printed at 0.3. The overhang is too high. So we're going to be doing 0.2. Set it to first layer and layer height to 0.2. Perimeters 1. Spiral vase mode selected. Solid layers 0 and 0. Some models will require a couple of bottom layers. Most do not. Most of this extra stuff I just turn off. Let's see, advanced I think it is. Yes. Okay, the most important setting you have to change is this setting right here under slicing, slice gap closing radius. Okay, this is the one that's not going to be 0 unless you've already changed it. It's going to be some number, and that number is going to cause it to delete the ribs in the model, which is going to break the entire model. You have to set this to 0. Okay, I turn it to regular. I change everything else to basically 0. I didn't bother changing this because it's effectively 0, so I'm leaving it alone. Overlap 25%, leaving it alone. You also need to change this. 0.4, 100%, 0.4, 0.4. Basically, we need to turn off all the smarts in the slicer. We need to make it a dumb slicer. Otherwise, it's going to get creative trying to fix things that it thinks are bugs. There's nothing wrong with the slicer. It's just what I'm doing is bumping up against the threshold of things that the slicer considers to be errors. Under filament settings, a setting you're going to want to get learn to access is this one here, extrusion multiplier. Most of mine, I start with 0.96. This is basically a way of tweaking the flow rate, how much filament it extrudes. If you have a problem where some of the ribs do not fuse correctly, you might need to bump this up a little bit, especially with PETG. If you have over extrusion issues, you can bump this down a little bit. The rest of these you shouldn't have to change, but that one you'll have to change. This model is being sliced in PETG, so I'm using 240 and 75. Under cooling for PETG, 35%. Let's see. Turn off enable auto cooling. I guess I have to have it on. Just set the min and max to the same. Okay. Do we have to change anything in printer settings? I don't think so. I think that's it. Here we go. Under extruder 1, layer height limits 0202. Okay. Extruder offset 0. Retraction doesn't matter. We're not going to be retracting. The reason we do this is we want to disable any smarts. We want to disable automatic layer height adjustment because that's going to affect the model. One of the problems with slicers, and this actually applies to all slicers, I found out, they're all using basically the same math algorithm. How do I know this? Because they all do the same errors. Some of my models are going to be difficult to slice in Prusa Slicer because Prusa Slicer does not allow you to define the start point. Prusa Slicer picks the start point. You might be able to put an additional object in here and then use sequential printing to tell it to print that first, and that'll start the slice in the center. I don't know how that works. I have not played with that yet. So for example, this model is going to be very difficult to slice in Prusa Slicer because this transition from a wide object to a narrow object causes a problem. I know how to fix that in Simplify. I do not know how to fix that in Prusa. I'm still working on that. So I'll be including G-code for PLA and PETG. All of these models will fit on, almost all of them, will fit on a 200 by 200 by 200 build volume. So it'll fit on your Prusa, it'll fit on your Ender 3, it'll fit on your CR10. Yes, you can slice a 200 by 200 G-code on a CR10, that's fine. The only printers that might have trouble are printers that have to auto bed leveling. Michelle, please be quiet. I can't pause this. So once you change all those settings, you're going to want to click Slice Now and slice it. But first, the math algorithm problem. For some reason, the physical height of the model can be a critical factor in whether it will slice correctly or not. So for example, if you tell it to slice a model in vase mode, and that model ends up totaling, let's say, 135 layers, but you're slicing at 0.2 millimeters. Well, 135 layers cannot be evenly divided by 0.2. So your model needs to be 134 layers or 136 layers. In most cases, it cannot be 135 layers because that leaves you with half a layer extra. And for some strange reason, instead of putting the squish layer, the glitch layer at the beginning or the end, all these slicers just drop that glitch somewhere randomly in the middle of the model. I don't know why. It's not a Prusa Slicer thing because Prusa Slicer does it, Cura does it, Simplify 3D does it, Idea Maker does it, Flash Print does it, they all do it. So they're all using the same algorithm, and the algorithm has this error issue where for some reason it drops the error directly in the middle of the model in a random location. Sometimes you can fix these errors by simply rotating the model. I do not know why that works. Don't ask me why that works. I can't tell you. You're going to have to ask the software engineer that. Because some model, I rotate it 5 degrees, problem goes away. I rotate it 180 degrees, problem goes away. I don't know why. It just does. So play around with rotation a little bit. The other thing is you can change the size of the model. But the thing is you have to double click the model, and over here you see your size. Let me change this into a window. There, your scalings here for the model. You have to turn this off. You don't really need to, because most of the time you're only making a micro change in the model. But if you make a small change and you don't make it to all the models, that can cause you problems. So what you need to do is, like this one here, like this was 187 millimeters in Tinkercad, but for some reason I can't explain why. I'm sorry, 54 millimeters. For some reason I can't explain why it's 53.69 millimeters here in the slicer. Well, that's a problem. That's not divisible by 0.2. This needs to either be 53.6 or 53.8. Cannot be anything else. It has to be evenly divisible by your layer height. And that's one of the reasons I don't do mixed layer heights. I don't do like a first layer at 0.3 and then the rest at 0.2, because that just causes problems, because now you have to do one layer at 0.3, subtract that number of layers from the model, and divide the rest of the model height. So you'd have to take 53.69, subtract 0.3 from it, and make sure the remainder is divisible by 0.2. So what we're going to do, in order to not mess with the X and Y dimension of the model, because that will mess with whether they fit together. This is a one-piece model, but most of these models are multi-piece models that thread together. So if you start messing with the X and Y, these models are not going to correctly fit together. So what we want to do is we want to just tweak the Z a little bit, just a tiny bit. You see this little padlock? Turn that off. See how the padlock is open now and it's orange? Well, now I can change Z without changing the rest. In this case, I'm right in the middle, so I'm just going to make it a little bit taller. I'm going to go to 0.8. Really? So now the model is 53.8 millimeters tall. Oh, you just had to do that, didn't you? I don't know why I did that. The model's just gone for some reason. Oh, there it is. It came back. Don't ask me why. It came back. But anyway, well, I can do this now. There we go. There's a model. Now, that all messed me up. Move, center, arrange. There we go. Wanted to make sure it was in the center. Now, now that the model's 53.8, it's a fixed whole number of layers. It's not a number of partial layers. If you want to test this, take this number, 53.8. So 53.8 divided by your layer height, 0.2. 269. So it's a whole number of layers. This model cannot be sliced at 0.3, and most of these might not work at 0.3, but let's say you are going to do it at 0.3. 53.8 divided by 0.3. It's not evenly divisible by 0.3. There's a decimal place. So what you want to do is go up or down. Okay, let's say we want to go down since we're closer to the down. 179. 179 times 0.3 is 53.7. So I have to change this to 53.7. And now I can slice it at 0.2 or 0.3. Okay, so you have to make that small micro change. Then we slice the file. Now once it's done, we come in here on the side and we inspect it. We make sure there's no missing layers. See, they're all solid. There's no gaps. Yep, no gaps. Check the inside. You seeing through it is no big deal. We're looking for gaps. We're looking for hard gaps. Go all the way around. I don't see any gaps. Come outside. I don't see any gaps. Okay, we're good to go. This model will slice just fine. I don't know why that happens. It just changes the size of the file for some strange reason. If you want to, you can now export this file. So when you go to print it again, you don't have to change the size of the file again. Be careful doing that. Save it as a new file and verify that new file slices correctly first, because sometimes Prusa Slicer and other slicers make a change to the file that then breaks the file and it stops slicing correctly. Again, I don't know why that happens. Just be careful with that. Keep your original files. If you bought a CD from me, then you have the originals on a CD and you're safe. But if you bought a download, keep the zip file so that if something happens to the file, you can restore it from the downloaded original. Also, if you bought the files on PayHip, as long as you keep that original email, you can re-download the files in the future. That's very handy to do. So you can actually put a text file in the zip file if you want on your hard drive and add the link to it if you want. Save that original email. This way, if I update the files in the future, if I improve them, if I add features, you can re-download the files as long as you keep that original email. If you do not keep that original email, there is nothing I can do. I cannot access any records. So do not, that's your receipt. You gotta have your receipt. As far as I understand, that link will work in perpetuity. As long as I keep my store online, that link will work for forever. That's it. If you have any questions, ask down below, but this is how you slice my files inside Prusa Slicer. I have a separate video on testing the prints. As you can see, they have ribs in them that have a slot going through them. That slot is 0.02 millimeters thick. I've learned not to use 0.01 when you scale things. It gets wicky. It gets weird when you do that in Tinkercad. This is designed for a 24 millimeter motor mount. You cannot scale these models. You can scale them a tiny bit. So for example, if you find out this is too tight for your particular 24 millimeter tube, you can scale it a couple percent to size it for your particular tube. That's fine. But you cannot, for example, scale this to 29 millimeter. It's not going to work. When you, well, it might work, but don't come crying to me if it shreds. Because what's going to happen is when you scale the dimensions of the model, it's also going to scale this gap. And this gap is a specific gap. It is 0.8 millimeters because the model ends here on the inside and the model ends here on the outside. And this piece of filament is 0.4 millimeters wide, and this piece of filament is 0.4 millimeters wide. This here, that point right there, is considered the outside edge of the model. So you need enough space, 0.4 millimeters to cover this bit, and 0.4 millimeters to cover this bit. If this gap gets smaller, which you can do a little bit, it's good. Like if you try to go down to 18 millimeters, this will not slice correctly. It's going to perforate the outside of the model. It's going to treat it as a cut instead of a rib, and vase mode will break. Even if it does work, it's going to look pretty ugly. And if you try to make it bigger, this gap will get larger. There is some wiggle room. 5%, maybe 8% you might get away with, especially if you over extrude a little bit. But eventually you're going to make that gap too big, and what's going to happen is the inside of the model will not fuse with the outside of the model. So you can see there's an inside wall and there's an outside wall. And they will no longer, and these ribs fuse those two walls together. That's what gives you your structural integrity. That's what gives you your strength. That's what makes this model as strong as it is, even though it only weighs 27 grams. Okay. So if you can see that in here, if you push that too far, this inner wall will not fuse to this outer wall via these ribs that you can see here. And it'll basically be a floppy model. It won't have any structural integrity, so you can't scale them. Every time I scale these for a different tube diameter or a different motor diameter, I have to basically remake the model. But the advantage is you get a wicked little saucer like this that only weighs 27 grams and it's made of plastic. It's pretty cool.